Hello and welcome to the webinar Best-in-Class Groundwater Monitoring, introducing the new ecoLog 1000. My name is Peter Schäffeler. I'm the responsible product manager for datalogger data management at Hydromet in Kempten, and I'm currently working from home as many of my colleagues, and I guess also many of you listening or watching me from home as well. We have today a webinar regarding groundwater monitoring and a new device which we have released last year in August. But before we start with the webinar itself, one organizational topic. Give me a second. Okay. You are all on mute, so that means you cannot talk to me. But if you have a question, you have the possibility to enter this question in the tool. There is a small box. You see this here on the slide. And if you enter here a question, the question will show up here on our side. The plan is that we answer the questions at the end of the presentation in a question and answer section. I might answer a questions in between if it fits, but the basic plan is to do this at the end. And but you can of course post the questions anytime. You do not have to wait until the end. Just put the questions into this small box, and then we will see it here. And another organizational thing, at the end of the meeting, when we have more or less closed it already, when also the question and answer section is done, there is a small feedback questionnaire about how you like the webinar and so on. If you have some time, please take this 1 or 2 minutes. I think it's only 3 or 4 questions you can rate or answer there. Okay, that's enough for the administrative stuff. So let's start with the topic today. The topic today is that we talk about basically about a new device. But before we do this, we start with information about groundwater monitoring, what is done, how it's done, the ways of monitoring. And when we have covered that, we will switch over to introducing a new device from our company, which is called the ecoLog 1000, a new groundwater measurement device. And then it will become a little bit technical when I talk about the technical features and show you what we have here on board and how the whole system works. When we have done this, then, as mentioned earlier, I would take questions and try to answer them. If I do not have an answer for a question, or if we are not able to cover all of the questions, because if there are a lot coming in, we will, of course, try to answer them after the webinar via email. Okay, so let's start with information about groundwater monitoring. What is groundwater level monitoring all about? It's basically just measuring the water level below land in a well. And actually, we do not even measure the water level. The direct measurement is a pressure measurement, and this pressure measurement corresponds to a water level. You have normally a network of various observation wells or monitoring wells. The water level is measured there, and sometimes we measure also water quality, like salinity or conductivity. And lately, we see also sometimes requests for nitrate measurement. But I would say 90–95% of all groundwater monitoring measurement systems is pure water level measurement. The frequency of measurements can really vary very wide. We have measurement wells which do not have any measurement equipment in there. So where you travel there, where you take a contact gauge and you do your measurement, you can do this every month, every 3 months, once per year, maybe some just every 5 years. And then we have also wells where you even measure every 5 minutes and or every minute, and then normally you log the data in a data logger that you have the data later available if you go there to read it out locally, or you use transmission technology. And as mentioned that, so we have a combination mainly of unattended instruments and manual measurements. I would say still the most measurement wells are manual measurements, where you go there with a contact gauge and do a manual measurement. Why are we measuring groundwater? Because we want to know conditions in the aquifer, what is going on with groundwater, what are the aquifer conditions in terms of the level, how it develops over time. And here it's very important also the development over time of those aquifers. And why is this so important? We will see on the next slide here. Of course, groundwater is very often a main source of water, of drinking water, of irrigation water, and therefore it's quite important to know what is the status of the groundwater. Is the groundwater level increasing, decreasing? Do I have to take actions based on this information? Maybe give out an order or a limitation of irrigation use of groundwater and so on. And of course, I want to know what are annual and long-term changes, because I need this to plan also how can I plan with this water availability. And also important to estimate recharge rates and also the direction gradients of groundwater flows. It's becoming more and more important, even here in Germany, where we have a quite healthy groundwater system. We had last year a very dry year, and it seems that this year is following the last year, which is not really good. It's beautiful, nice weather, but we lack definitely rain. And this becomes more and more an issue. And then if we look to the south of Europe or other regions in the world, it will become more and more important to know, okay, what is the status of my groundwater and what can I expect to use the groundwater and how to use it. And this actually gives me an information about the health of the aquifer. But this is one piece, and another piece is we are not only talking about decreasing groundwater levels, but also fast increasing groundwater levels. When we have flood events, storm water, what we also see now much more often, the groundwater level can also increase very fast, and therefore we have danger that a basement is flooded or in construction areas that the construction area is flooded. So therefore, we're not only detecting a falling groundwater level, but also rising groundwater levels in terms of damage protection. What you see here is, for example, a groundwater well close to Kempten, where our company is located. This is a time frame of 7 years. Here we have a line where it's the mean value, and then this is the way how the groundwater level here developed, and the geologists or hydrologists can use this data and read out some valuable information out of that. Okay, why do we want to do continuous monitoring with data transmission? This has quite some advantages compared to the spot measurement or a measurement where you have a device there, but you have to travel there to read out the data. You have the possibility to do a constant monitoring on a very regular basis. So you get a better possibility to track the groundwater level, and due to this, you have a better decision-making process because your data is more accurate, more timely, and more detailed. And the data could be also, if you do a continuous monitoring with data transmission, available almost anytime, anywhere. So we see here some field stations, and then you send the data to a server, and the server provides the data in a data center, in a network management center. So here you have always this data available without traveling to the site and do manual readouts, writing the data by hand in a table and process it. So you have here a fully automated process, which is in terms of equipment more expensive than a manual reading. But of course, in the process, it might be even less expensive because you save a lot of travel time, resources, and you are much more accurate with the data. Yeah, I talked already about the advantages, but here a collection again. So we measure, collect, and transmit precise and accurate water level data. It's an all-in-one system. You do not need to do here a lot of things. You have a system with power supply, with the batteries, with the sensor, with the logger and the modem. And you have the possibility to collect more data more often. So you are not relying on traveling there. You have the data when you need it, and you have definitely more data available. It's also important where you need data almost in real time. I'm a little bit hesitant to use the term real time because this is not real time, but when we compare it to drive to a site every 3 months and get the data maybe once per day or every hour, compared to this, it's more real time definitely than it was. But you have maybe locations out there where this is required. I talked earlier about construction areas, and maybe then you also equip this with such a device, and then you also can use the possibility to do alarming and then react on events. You have the access to the data anytime, anywhere, because it's on your server. And you really detect changes in the water table much better, and you can better act on this information. And I mentioned that already, this becomes now more and more important due to the impact of drought and climate change. Again, we see this here in Germany, we see it all over Europe. I think it's a global thing, and this is really a new challenge we have to cover. And water is one of our most important resource, so we need really to know how is our whole water cycle behaving, and groundwater is one important piece of that. So where do we measure? A typical measurement is a groundwater in-well solution. We see this here. This is, by the way, that's me, Peter. This is a well. We have your well cap, and I just took out here the device. And here you see a contact gauge to do a control measurement, but it can be also used for surface water-like applications, like we see it here. A colleague of mine, Helmut, some of you know him, where you have then all-in-one surface water level system, very tiny, small, no big construction work required, very simple to set up. And from, and what we see here is an underflow measurement side, and this here is a pumping station in the US. This is a gentleman from USGS. The locations are urban or remote locations, very remote. What is of course important, if we want to get the data to our data center or data system, we need a mobile signal, so mobile coverage from a provider to get the data there. And it's used in most cases in fresh water, some in brackish water, and very rarely in saltwater condition, but most applications are freshwater applications. Okay, and how do we measure such things? We at OTT, we have various products to measure groundwater. Some of you might know the Orpheus Mini, which is a data logger without telemetry, logging the data. Then the ecoLog 500, which has then also telemetry options, and the ecoLog 1000 is now the next step with more features and more advanced telemetry options than, for example, an ecoLog 500. So this device is mentioned for groundwater monitoring, but of course can be also used in surface water level applications. We measure basically a water level with this. The communication technology is cellular, so no satellite or analog stuff or radio. It's cellular communication technology. The readout of the device locally is done with Bluetooth, and can be now also done with a smartphone, which runs on Android or iOS, or a tablet on Android or iOS, but of course as well with Windows 10 devices. It's also possible to access the device remotely via two-way mobile communication. It's network management capable. How this works, I will show in this presentation to give you an idea what options or possibilities are available here. And it's a robust design, ceramic pressure cell for the level measurement. We have a very high quality stainless steel device here. And we have intelligent power management to increase the battery lifetime. But I will cover this also later in more detail within this webinar. Okay, when we talk about the groundwater solution, we are not talking just about a groundwater sensor and the transmission technology. It's actually a complete system, and I try to show that here. So the ecoLog 1000 is just a part of a system. So this would be our measurement site, and to configure the device and to control values, I need to communicate with the device. I do this in this case, as mentioned earlier, with Bluetooth, with a smartphone or tablets. To get the data to the center, I need some kind of mobile coverage. In this case, it's a 4G, 2G network. In future, we will also have LTE-M or Cat-M1 available. I will cover this also later. And it's still text messaging possible. Then you transmit the data to the internet, and from the internet, it goes to a server. The server could be an HTTP server, it could be an FTP server, it could be a secured HTTP server or HTTPS server, for example. And now you have the data here available, and the data could be made available in a central office, could be made available via the internet. Here you see an example of Hydromet Cloud on smartphones, and you can also work with the data of the logger to do also network management. So this would be the complete system from the device to data visualization and storage of data. Okay, so we covered the system. What are the technical features of the ecoLog 1000? First of all, I mentioned that it's an IP data transmission. So we are not talking about satellite or analog. It's an IP data transmission. The version 1 is a version with mobile LTE, so it's 4G. And if a 4G network is not available, it will fall back to 2G, GSM, GPRS. Important here, 4G networks are now becoming more and more prominent to certification. So this version is a European version at the moment, where we have the certification there. And then a second version, which is the global version, is in preparation. It's also 4G, but it's called 4G LTE-M or Cat-M1. So this is a 4G standard for exact applications like this, but with much lower bandwidth than this standard here, because the normal 4G standard you would normally use for you know, streaming videos, Netflix, YouTube, and so on, but you don't need this kind of bandwidth for a groundwater monitoring system. Therefore, the providers are working on a lower bandwidth solution, and one is LTE-M, or Cat-M1 is called in the US. And there is also another technology out there which is called NB-IoT, but this is then again something different. Okay, having said this, sorry, ran to the wrong direction. Having said this, it's IP, it's also time synchronization possible. That means the device always checks when it does an IP communication on a server, is the time still okay? It did not drift, because every time in a battery or a solar powered system is drifting, and here the drift will be then eliminated by this time synchronization. So you have always accurate data stamps. It's possible to do redundant data transmission. So you can do 2 transmission to 2 servers each. That means you have up to 4 servers. And what is nice here, you can do a transmission to a server with fallback to another server. That means you send to server A. And if this server is not reached, then the device automatically falls back to server B. Or you can decide, oh, you want to have the information always on both vendors, both servers. Then you do a parallel transmission. Then every data package is sent to both servers in parallel. And as mentioned, it could be up to 4 servers, and these servers do not have to be the same servers. Could be FTP servers and HTTP, FTP and HTTPS. So this is completely freely configurable. Another feature, we still have SMS data transmission and SMS command. So SMS is still technology used. So it's possible to send the data via SMS. In this case, it's a binary protocol which needs to be decoded on the other side. It's just due to the fact that you do not get too much data into an SMS. And you can also change some things with an SMS command. For example, a transmission interval, you send an SMS command and then the transmission interval is changed. So this is still in there, even it's quite old technology, but it's still supported. Secure data transmission in some countries becomes now very important. In some, it's not important at all, but basically you have the possibility to enable here a secure data transmission, TLS 1.2, HTTPS transmission, and it's really state of the art. It supports all latest technology, and it's also future safe as it's already ready, excuse me, for the next standard, which would be TLS 1.3. We feature different formats with the ecoLog 1000. There's an ASCII format, which is our MIS format, an XML format, which is the HTML format, CSV, so comma separate values, and ZRXP, which is a special, or not a special, it's a format used in the Kistos world, for example, to send data to a WSGI server. Besides the measuring data, which is typically the water level, the water temperature, we also measure and log metadata like the power consumption. I'll talk about this in a minute. The supply voltage, RSSI is the signal strength, and we measure also the humidity in the communication unit as a flag in the header of the HTML file. So metadata, for example, the power consumption, this one is measured. It's really measured how much power is consumed, and so you know always how much power is already drawn from the battery. And for example, it's possible to set an alarm or a limit to that, and then you know, okay, the next 3-4 months I need to replace the battery, but you are not running out of battery because you always have the status of the consumption of the battery. So metadata is a quite important thing. Maybe some more metadata which are not listed here, but you get, for example, metadata like who is the provider, what IP address did you get. You can also enter in the device the longitude and latitude. If you then send the file, for example, to Hydromet Cloud or to Hydra 3Net from our company, then you could show the device directly in a map because the longitude latitude information is also available. So there are much more metadata available, but these just as the most important ones shown here. Okay, action management, also very important. The sending of alarms could be based on events. For example, if you cross a threshold, means, for example, you have a flood or a stormwater event and the groundwater level increases very fast, then you get an alarm, tells you, hey, listen or take care, there is the groundwater level at this well has crossed this value and it might become now critical. And what you can do here also is that you adjust everything. That helps you also to increase dramatically also your battery lifetime. For example, let's assume you have a groundwater well, and you know, okay, it's quite stable there. So you measure every hour and you transmit the data once per day. And then you have a secure system there measuring every hour, transmitting once per day. Then you can look normally to a battery lifetime of 10 years or something like this. Now let's assume something happens there and the groundwater level rises. You detect that you crossed the limit or a gradient. Then you say, okay, let's wait. Now I'm the logger, the ecoLog 1000. Something is going on here. I need to measure more often. So the device switches over to a measurement interval of 15 minutes, and maybe I transmit now every 2 hours because it becomes critical. Now the situation becomes even more critical. Then the ecoLog switches to a measurement interval of every minute or every 30 seconds and says, okay, now it's that critical. Now I transmit the data not every 2 hours, but every 15 minutes or something like this. And then you have very fast the data available on a very short period. And of course, if those events which caused to switch those measurement intervals or transmission intervals to a different value are gone, then it will switch back to the original values. So that means with such things you can really have data in cases where you need it, and if you don't need this frequent transmission, then you're not doing it, and you save a lot of battery. And actually the adjustment of the measurement intervals has some impact on the battery lifetime, but the biggest impact on the battery lifetime is the transmission interval. You can do data processing, you can create mean values, max min values per day, scalings, extremas, limits. Limits, for example, are used for the alarming. I just mentioned that. What is also new in the ecoLog 1000, the cable can be shortened in the field. You could use this to make the cable shorter or exchange the communication unit or sensor on site. You see here in the ecoLog 500, for those of you who know it, it was a soldered solution. Now we have here those clamp technology, color-coded, matching the color codes of the cable. So it's very simple to attach this again. The purple one here is the strain relief, and this transparent tube here is the capillarity. Okay. I talked about one thing that was network management, and I want to talk about this here in a little bit more detail, because the data logger sends data to the server on its own, so it pushes the data, so it's always there. But what is happening if I want to access the data logger from remote without traveling there, without sitting in my car and travel to the site and do something? In the past, there was a technology available called CSD, circuit switch data, where it was possible to dial into data loggers like a groundwater data logger with a modem. You need to add a maintenance window there, and then you could dial in remotely. This technology is disappearing. In Germany, it's switched off. In many other countries, it will completely disappear because this technology does not fit into the provider's strategy anymore. It's for them too cost intensive. They switch everything over to IP technology. And therefore, there is now a possibility to configure the ecoLog 1000 from remote with a software called Hydra 3net. And what is here very important, this is done via IP, but you do not need a static IP address on the logger side. And this is also sometimes very difficult to get. In some countries it's easier, in other countries it's very difficult, but static IP are either not possible or very expensive. And therefore we have a solution called Hydra 3net, which is based on our standard Hydra 3 software, where you could manage ecoLog 1000 measurement networks. And the nice thing about this is you can change configuration of single loggers, of some or of all in the network. Let's assume we release a new firmware because we added a new feature, or maybe we found a bug and we fixed it, and you have 50 ecoLogs in your network, and now you want to roll out the firmware update for 50 ecoLogs. In the past, you would have traveled to each site and do a firmware update, or dialed in 50 ecoLogs, one by each other or one by one, and do a firmware update, always with the problem that the transmission might terminate during firmware update. So those problems, we've seen them all. In this case, you would do a firmware update for the entire measuring network with 2 or 3 mouse clicks. And you have an easy and simple diagnostic status of the entire network on a glance. You come in the morning in the office, you have a dashboard. Let's assume again you have those 50 ecoLogs. Then you see the status of the 50 ecoLogs. Okay, what stations maybe have not sent data, what stations maybe have not enough battery power left, and so on. This is all what you see in the morning in the office without doing any interaction with the device. So you'll save a lot of time and money managing data logger networks. For this, but you need the Hydra 3net software. And how does it work? It's basically like this. You are here. This is your measurement network. Those are your ecoLog 1000s, and this is your server here. And this is the software. The software runs just on a PC. And now the data logger sends data to the server. And this is the normal operation. And now I'm sitting here, and now I decide, for example, these data loggers, these 30, 300 data loggers, whatever, measure the water level every hour. And I decide, now I want to change that to every 15 minutes for standard operation. Not alarming or something. I want to go in general from 1 hour to 15 minutes. Then I create here a command. This command is automatically placed here in the software. And this command says, please change for all ecoLogs, or the ones you have selected, you can select them, the measurement interval from 1 hour to 15 minutes. Now, the next time these loggers are sending data, they see, okay, hey, wait a minute, there's a command. The command is sent, and this command is then executed on site. And this command, in this case, would be the change of a measurement interval, but could be also a firmware update or a complete new configuration or different server settings. So you can also change maybe the direction you want to send the data to. And the ecoLog is executing the command and is sending back an acknowledgement. And then you get an acknowledgement. And in this case here, you would see, okay, 2 ecoLogs have changed the measurement interval from 1 hour to 50 minutes. At one side, it didn't work. Hey, wait a minute, let's check what was going wrong there, and you can do this from there. Okay, but this does not mean that you mandatory need only this software. I mentioned earlier that you can send to several servers, up to 4 servers. Now let's assume you have another data software, which is a second server. So you could send the data to the second server, which is your data visualization software, and you use this server, for example, only for maintenance or as a network management server. This is also possible that you just use this. If you send the data here as well, you have the advantage that you have the data also redundant here, but you do not have to do this. You can also send the data to another server and use this as a data visualization server. So that's the way how it works. Very simple, but that means you need the software here. But what is very cool, you do not need a static IP address. What we also have introduced just recently to the ecoLog 1000, if you don't want to use this software here, you can do this via FTP. Then you would just place an FTP command on your FTP server, and then it would work exactly the same thing. The only difference is you do this one by one, not for entire network, and you have to write a small control file which says, for example, please update the configuration. But this is also possible with FTP, but then you don't have this nice graphical user interface. You do it more basic with control files you need to create in a editor or something like this. But basically, it's also not very difficult. Okay, so much so much for the network management. Now let's talk about some technical features of the device. Battery desiccants are easy to exchange without tools. The ones who have used an ecoLog 500 know this from the ecoLog 500. You just open one screw by hand, and then you can open the compartment here, and you have access to the battery, to the SIM card, and the desiccant. That is very easy doable, especially when you're doing this outside in the field when it's cold. Maybe you have stiff fingers and so on. So this is a very easy way to do all these things. The whole power scenario is on the top. So that means on the top you have the battery, you have the modem, you have the logger. There is no battery in the sensor and therefore in the water. So if there is a battery exchange required, you do not pull out the sensor out of the water. You can leave the sensor in the water. This is quite handy if you have 50 meters cable or 100 meters of cable. You do not have to pull it out. Open a sensor, and if you need to replace a battery in a sensor, this is always more difficult and cumbersome because of the high IP rating there, or at some vendors you even have to ship it to the manufacturer to change the battery in the sensor. So in our case, no battery in the sensor. The whole system is powered from the top. A question I get very, very often is how long does the battery lifetime, or how long does the battery last? So this question is very difficult to answer because it depends on so much variables. It depends on the intervals, mainly really the transmission intervals, of course also measurement intervals, but the transmission intervals are much more important for the battery lifetime. And what also needs to be considered is the temperature cycles. Sum of rule, the colder the environmental conditions are, the shorter the battery will last. But in our case, what we did is we have now an actual consumption measurement in the device. So we measure always how much power do we need and how much power do we draw from the battery, and so we get a real good indication. And you see this here, this is an own measurement channel. This is a brand new battery because it shows here the power consumption is 52 milliamp hours. The battery is a 26 ampere hour battery, so 20,000 milliamp hours. So this is a brand new battery. And for example, you could now say, okay, when you reach your 20,000 milliamp hours, I send an alarm, an SMS, hey, I've crossed this threshold. Maybe it's a good idea to change the next 3-4 months the battery, or 5 months, and then you are warned, and you can really avoid that you have here the problem of an empty battery. Maybe also one topic here, if the battery is so weak that it's not possible to transmit anymore, we designed the system in a way that it's still good enough to do at least, and it's not exactly quantifiable, but 10 to 50,000 measurements. That means now the battery is not strong enough to transmit anymore. You do not have data gaps because the battery is still strong enough to continue to measure. The system then stops transmitting and does not try it anymore. And if you replace the battery, you still have all your values in the logger and you do not have any data gaps. Here an example, 4G, 2G, the battery lifetime 10 years at average temperature 20 C, 1 hour sampling and 1 hour transmission per day. So this seems to be very theoretically, but actually in Middle Europe, 20 C as an average temperature is not too bad. It's somewhere between 10 and 20, considering winter and summertime. Higher temperatures are not too bad. But so this is not too far off the reality. Now, of course, if you are in Greenland or somewhere, then of course you have a completely different situation, or on in the Alps on very high altitudes where you have very low temperatures. But with this average, you are quite good here. So what is also new, it's a wireless local operation via Bluetooth Low Energy. And what is the special thing about this? You do not need to activate it. It's always activated. It's low energy, so it's advertising all the time in the microamp range in terms of power. So this does not really impact our power budget. And you do not need to activate the Bluetooth or use a dongle here. This is not required. In this case, for example, if I would like to do here communicate with this device, you could even close this well cap because this is an eco cap. You do not even need to open it, and you can communicate with the device via Bluetooth. So no dongle or nothing required. And you can use not only a Windows PC or Windows 10 PC, now you have also the possibility to use a Android or iOS device, a smartphone, a tablet. The app it can be found in the app stores. For Android, it's the Google Store. iOS is the Apple Store. It's their free download. And the Windows version is found on our website like our other operating programs. So what is the interaction with software? Of course, the device interacts with Hydra 3 Net with the network management. I talked already about that. HydraMed Cloud, which is another product from HydraMed. It's also tailored to work very seamlessly with Whiskey, which is a Kister solution. I mentioned earlier a data format which is called SetterXP. So you can send data directly to Whiskey to the server without having the need having additional equipment in between, like a soda or something like this. And of course, other customer data visualization software. It really depends what formats can you accept. So as mentioned, we have ASCII, we have XML, we have CSV, we have ZRXP. So we are here very flexible. This slide here is a summary of all the things I just talked about. And I put that in here because when you get the presentation, you have more or less on one glance all the information available. And I don't want to repeat all this stuff again, but those are the key features of our new ecoLog 1000. With this, I want to I'm at the end of the presentation, and I would now switch over and answer questions. And I saw that there already some questions came in, and we would like now to start to address them.
Thank you, Peter. The first question: local communication is only available through Bluetooth. You cannot communicate locally with any other connection, e.g. wired connection, or?
That is correct. The only communication you have locally available is the Bluetooth communication. We wanted to avoid to have here any kind of connector or something there, and therefore the only connection possibility is Bluetooth. The old cable from ecoLog 500 or 800 is an infrared interface, and this is not in the ecoLog 1000 there anymore. This has more than one reason, maybe also to give you some feedback. Infrared is a technology which becomes more and more old, and is also, it's at the moment almost impossible to source any components anymore which are doing infrared. So infrared in applications like this are fading away.
And what about a cable like for ecoLog 500?
Now that is the infrared interface.
Okay.
You need really just a Bluetooth communication. There is and if you have the ecoLog 500 and the cable, you cannot use it with the ecoLog 1000.
Okay. Next question: do we need to ask our providers for a specific 4G LTE SIM rather than a standard 4G SIM?
No, it's you use just a standard 4G SIM card you use today in other data loggers. This is a standard SIM card. The size is a mini SIM card. Nothing special here. The only thing, if in future we have those LTM or CAT-M1 standards, then you might have a different frame contract or a different SIM card from the provider. But for time being, standard SIM card.
All right. The next one, I think maybe that was mentioned before, but I will, however, ask it. Logging to ecoLog 1000 is only possible by LinkComm, or can we log with other water logger software?
No, same as for the cable. The water logger software is our water logger operating program for ecoLog 500 and ecoLog 800. The ecoLog 1000, we really made here a hard cut, and the hard cut is that we use only LinkComm, because we have here the possibility also to offer this as an app, and therefore decision was to do here a hard cut and offer one program to configure the device, which is in this case LinkComm.
Okay, next question. Are you able to add additional protocols to the comms, such as open protocols like DNP3 or MQTT, to allow connection to other SCADA systems?
This is a good question. So it is not possible now just to that the customer can decide that he wants to add another protocol. We have the protocols defined, and those are the ones we have shown in this presentation. But it's quite a coincidence. You mentioned your MQTT. We are at the moment running a trial with MQTT, and we plan to offer MQTT with the ecoLog 1000 as well. But again, this is at the moment a trial. We have set it up and we do some tests here. But most likely, I cannot guarantee it, but most likely MQTT will be one of the features in a future release of the firmware.
Okay, if the battery level drops so that transmission stops, when you replace the battery, will those values not be transmitted then? So the data gap on the server is filled in. What? Sorry, that's the transmitted then
So,
be sent. Yeah, I think you got it.
Yeah. So the question is, if data is not transmitted anymore, but the device still locks, and if I then replace the battery, then of course the ecoLog 1000 automatically will resend the data to the server and fill the gaps on its own, because the ecoLog 1000 knows that for this time period the data was not sent to the server and will do automatically a resend.
There's one question I can answer. You will all get a recording of this webinar tomorrow. So don't worry if you maybe missed something or somebody couldn't make it, you will get a recording of the webinar. So next question for Peter. Can we have a Hydromet cloud? Can we have Hydromet cloud on a local server?
No, this is not possible. Hydromet Cloud is purely a solution which is a hosted solution from us. If you want to have a solution on your local server, you might consider to look to something different like Hydra 3 or Hydra 3 Net.
Okay, so one more question. How can we integrate the data of ecoLog to third-party software?
So you need to, so we sent the data to an FTP or HTTP server, and we sent the data there in the formats I've mentioned. It could be, let's take an example. We sent the data per CSV to an FTP server. Then you have the CSV files on the FTP server. And then with a third-party software, you would grab those CSV files from this server and integrate it into your system. Then you need, of course, to have the possibility to have CSV import, or you have an ASCII import. That would be the typical way how you would do that.
No more questions so far. Oh, sorry.
Yeah, but I see here something, because I see people which are not from Europe here. I mentioned that in the beginning, the new telecommunication standards are becoming more complicated than in the past. In the past, 2G, 3G were global standards where you could, which could be used in almost every country. Now, in the last couple of years, there were a lot of changes there. That means not only 4G, but also any telecommunication devices or devices which do some kind of transmission need country-specific certifications. That means the ecoLog 1000 at the moment is certified for whole Europe. We have a certificate for Australia and New Zealand, and we are working at the moment in the US on AT&T and Verizon certification. All other countries, we need to do a case-by-case evaluation. This is a very uncomfortable situation, and we're happy about this, but this is something we cannot change, and which of course will faced by everybody who is offering such a device. So for example, if somebody from Latin America have bought in the past ecoLog 500, it's not possible now just to switch to ecoLog 1000. We really have to look into it. What are the regulations there, and so on. So this became a little bit more difficult. For this reason, we also still offer the ecoLog 500 and 800 in such countries if we want to have a faster solution. In Europe, the ecoLog 1000 will replace the ecoLog 500 completely.
Okay, so no more questions so far. Of course, you can also ask us afterwards via email if there's something coming up afterwards.
Yeah, I just saw that somebody asked a question which was already answered, but did not hear it because of lost connection. ecoLog 1000 mandatory requires LinkComm. It's not possible to configure it with the waterlogger operating program from ecoLog 500 and 800. Yeah, and the last question: 3G communication needs an ecoLog 500. We decided on purpose not to support 3G on the ecoLog 1000 anymore. It's 4G fallback 2G because 3G is in most countries not an option anymore. In the US, it's completely gone. In Germany, it's switched off also soon, as in the most other European countries. Some countries make some exemptions, but the 3G frequencies, the UMTS frequencies, will be used for 4G and 5G in the future. Okay, thank you very much for your participation and for the questions. There were many questions that showed me that the interest in this technology. I wish you a good day, and we have more webinars still pending. I think there are some for surface discharge measurements, some webinars. Check out our blog post. There you find additional information about webinars. And thank you very much for your participation.
Yeah, thank you also from my side, and would be nice to see you on other webinars. Take care and bye-bye.